Pleasant morning to one and all. I am Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering. Today I am going to discuss about an evolutions of transformers in neural networks. The evolutions of transformer basic concept of transformers emerged from the need to overcome the limitations in sequential model like recurrent neural network and convolution neural network, which struggles with capturing a long range dependency effectively. The transformers were introduced in the sentimental attentions in all of needs by revolutionary NLP by demonstrating the superior performance in tasks like machine translation. The self attention mechanism, the basic motivation towards is all about the traditional sequence model process the input sequentially, which hinders capturing the relationship between the distance word or a token effectively. And the concept behind is all about the self attention allows each words or a token in a sequence to attend to every words computing a weighted representation that consider the importance of each words relative to the recurrent words. This was the basic evolutions of the transformer model, where it enables a long range dependency and context relationship without any sequential processing constraint. And understanding the transformers where falls under the enhancing the expressiveness of self-attention by allowing a model to jointly attend to informations from a different representation subsequence at different position. In each attention head, the input is linearly projected into a query key and the value vector were then independently attended to before being concatenated and linearly transformed again. The facilitating it captures the different types of dependency and the patterns in data, improving the model ability to learn and generalized. The basic transformer architectures was involved with the in self-attention mechanisms, and these self-attention mechanisms will be used for the variable input calculations with the computation attention scores between every pair of position in the input sequence using a scaled dot product attentions where queries keys values or linearly projected transformations of input embedding, where we also have a QKV that has a self-soft matrices with the different left matrices too, allows our models to jointly attends to the informations from the different representation subspace at different positions and splits these embedding vector into multiple heads, computes attentions independently with each heads concatenating the results. And hence, the self-attention mechanism benefits a model ability to capture a diverse relationship and patterns within the data. The multiple head attentions, the basic necessity towards it is all about compensate for the lack of sequential informations in transformer which otherwise process the tokens like parallel. The encoding methods including a sine and cos functions of different frequency added to the input embedding provides a model with the informations about the order of token in a sequence lying in the learning of a sequential relationship. And the basic mechanism which falls under these applications of splitting attention computations and so on. So the basic necessity of all these process of head, multi-head and multi-head attention is using your self-attention and masked multi-head attentions to prevent attentions to future to generate the output sequence based on the encoder representations. We have the basic process of enhancing expressively of self-attention by allowing a model to jointly informations from the different representations of different position. The future representations of these transformer models will help you for the basic aspects of understanding in evolutioning process, and these applications will also be help us in efficiency improvement reducing the complexity, exploring a technique to reduce a computational complexity and the memory requirements and transformer. The spare attention, implementing a spare attention mechanism to scale the transformer to the larger input and model. Integration with other models, which where we call it as a hybrid model, combining the transformer with a convolutional or recurrent architectures for the hybrid model that leverages the strength of the different approaches. The application could also be extended to further process or a dynamic language transformers too. I hope you are clear with this future implementations in transformer model. Thank you.